Hello everyone, my name is Vicki Ellingrod. I am the chair of the education work group for Precision Health. Welcome to this online tutorial entitled How and Why to Use Your Star Allele Calls via U of M Precision Health's Data and Analytics platform. The tutorial is designed to introduce a new way to enrich pharmacogenomics research here at the University of Michigan. We will walk through an overview of the value of this information, how the star alleles can be used in research to expand research initiatives, and recent changes that have been made to make the data more available and how to access the data. We are joined today by two experts in this area who have helped develop this new functionality. Amy Pasternak, who is a clinical assistant professor at the University of Michigan College of Pharmacy, and Brett Vanderwerf, who's a research area specialist for U of M Precision Health. We will include contact information at the end of this video, and we encourage you to connect with us about any questions you may have. So let's get started. So the first question we have today is, what benefits are there to working with MGI for pharmacogenomic research?
Thanks, Vicki. That's a great question. The MGI cohort provides a lot of really great opportunities for both discovery and validation work with pharmacogenetics. Studies can be performed a lot more efficiently and cost effectively with this data than traditional study designs, because we aren't having to obtain and then genotype all of our own samples. Because the data is already linked to the medical record, there's the opportunity to evaluate these pharmacogenetic relationships for any medication you might be interested in. And for some really well-known pharmacogenetic associations, there may also be opportunities to identify patients who could benefit from clinical testing and research studies.
So what is the research potential for inferences of star alleles and phenotypes in the MGI cohort?
I think the biggest research potential is the clinical translation of this information. Most clinical pharmacogenetic test results are reported with this star allele terminology, and recommendations for modifying drug therapies are most commonly based on these pharmacogenetic phenotype terms, such as the metabolizer status. Having this research data already available in this nomenclature of the star alleles and clinical phenotypes makes the data even more clinically translatable, since these formats will correspond directly with what our clinical pharmacogenetic reports state.
How has the recently released star allele and phenotype data from MGI affected your pharmacogenomics workflow?
Prior to the release of this data from MGI, all of our genetic variants were being manually translated into star alleles and phenotypes. This new process is much more efficient than what we were using previously, and also really helps to ensure that all results are translated into these formats in a consistent manner among all of our studies.
So this next question is for Brett. What pharmacogenomic data are available from MGI resources?
Yeah, so I can provide more detail on what data are available and more specifics on the MGI cohort. So the most recent release of MGI data now includes inferences of star alleles and pharmacogene phenotypes for approximately 57,000 Michigan medicine participants. And we anticipate that this number of genotype participants will grow in the future. Currently, the pharmacogenomic data contains inferences for 382 distinct star alleles across 51 different pharmacogenes. And this list covers most of the commonly studied pharmacogenes. And so, as Amy started to mention, among the benefits of accessing these data from MGI is the cost-saving benefits. And this is because investigators can perform these pharmacogenomic studies without the needs to enroll study participants, collect specimens, and genotype samples, and deal with the costs associated with those processes.
Wow, this sounds like a really great resource. So how are the star alleles and phenotypes inferred for MGI participants?
So what we start with initially is a set of genotypes that are assayed for each participant using genotyping arrays. And then to further expand the number of genotypes that we can analyze, we use an imputation process, which statistically infers essentially millions of additional genotypes that weren't directly assayed. It's a combination of these directly typed and inferred genotypes that we use as input for the open source software Stargazer, which is essentially the engine that determines which star alleles are compatible with the given genotypes of MGI participants. And then in turn, Stargazer also uses those genotypes to translate phenotypes for MGI participants. And so we consolidate all of this data for investigators and provide it in an analysis-ready format. This is particularly helpful to individuals that may be interested in this resource but don't have maybe a strong programming background to access the data.
So what quality assurance approaches were used to evaluate the accuracy of the inferred star alleles?
So for 10 widely studied pharmacogenes, we evaluated concordance between the star alleles that are inferred by Stargazer and are called using gold standard clinical pharmacogenomic test platforms. And so for each evaluated participant, if the same unambiguous star allele was both called by the clinical test and inferred by Stargazer, we consider that concordant. And so using this definition, we find mean concordance rate to be 96% with rates ranging from 77 to 100. And data from these quality assurance tests are available upon request for investigative review.
So I can see where this is really a value added in MGI, in that it will really help people have greater breadth and depth in their research program. But are there limitations to these data that investigators should consider when designing or analyzing experiments?
So while concordance checks suggest that the MGI star allele inferences generally perform similar to gold standard assays for the pharmacogenes that we evaluated, some important limitations remain. So first, this is not a next generation sequencing based approach. So we can only infer star alleles that are defined by variants that are either directly genotyped on the arrays or were inferred with confidence by imputation. And so considering this, we have tables to help investigators understand which star alleles are inferred for a given gene of interest and which star alleles may be missed. Additionally, this method does not consider gene copy number. And so this limitation affects the analysis of pharmacogenes that are well known to exhibit extensive copy number variation and have phenotypes that are affected by that variation. And so probably the most well-known example is CYP2D6. So the ability to infer CYP2D6 phenotypes in MGI is affected by this limitation.
That's good to know. I know 2D6 is often one of the P450s that people really want to include in their research. So understanding the limitations, I think, are really important. How do interested investigators apply for star allele and phenotype inferences from MGI?
So there's, we try to make the process as simple as possible. There's really two steps involved in this. And first step, probably most investigators are familiar with, submitting an IRB application through doctrjira.med, which can be reached via this link here. And the second step folks may not be as familiar with, which is submitting a custom data request via the JIRA portal. So investigators can click this link to access JIRA, and after navigating to this site, they'll be prompted to log in with either level 2 credentials if they have them, or they'll select an alternative login if they don't have a level 2 password. After successful login, the investigator will be prompted with a series of options in the next page. They'll want to click custom data request just to access the custom data request form, and after which a web form will appear and the investigator will fill out this web form. And it's things that are going to be specific to their study, like the description of the design and then their contact information, things of that nature. They'll also want to ensure underneath the what is this request for in this web form that they select genetic data, just to indicate that they're interested in obtaining genetic data from MGI. So that's really it, just that two-step process, getting the IRB going through doctrjira.med and then submitting a custom data request through JIRA. To help usher investigators through this request process, there are precision health research scientific facilitators, which can be contacted via this email here. And then if there are any specific questions about the data production around star allele inferences and phenotype estimations with MGI, please feel free to contact me, again, Brett Vanderwerf, Precision Health Data Analyst, at this email here. Happy to engage anyone. And also Amy Pasternak, again, PharmD Clinical Assistant Professor, with her contact information here.
Great. Thank you very much, both. I think this is a great value added of MGI, and hopefully others will use this information to expand their research as well. Thanks.